Hello, everybody. Welcome to week 4. There's only 3 more weeks left of notes and assignments left after this week, so we're officially halfway. Starting this week, we're going to start talking about polygons, which is this whole first set of assignments and notes is going to be over. Then we're going to start talking about circumference and perimeter the second half of the week. So those are the two topics that we're mainly going to be talking about this week. All right. So first off, starting off with polygons. A polygon, it's just a closed figure formed by line segments. All right. So it's closed. All right. What we mean by closed is that it can't have that little gap right there. All right. All the sides have to meet, or they all have to be connected. All right. Also, it has to be line segments. So a circle or a heart or a crescent, all right? Anything that has curved sides, all right, doesn't count. All right, so we got to have straight sides, and it has to be closed. Notice we can have that little arrow-ish shape where it kind of pokes out, a star, all right? Anything that is straight lines, all right, and closed. All right. Now, where we're going to go with this first, all right, is that we have several different ways we can name a polygon. All right. The main way we do it is by its sides. All right. So we start with a prefix, just going for whatever number of sides, and most of them end with gon. Now, there's a couple of exceptions to that. The triangle and the quadrilateral. Those are both shapes we've already talked about, and as we kind of talked about when we talked about them being polygons, all right? A triangle is just a polygon with 3 sides or 3 angles. A quadrilateral is a polygon with 4 sides. Notice that includes all your parallelograms, rhombuses, rectangles, squares. All right? For the rest of them, we basically start using prefixes. If it's 5, our prefix for 5 is penta. So it's a pentagon. All right. If it's 8, our prefix for 8 is octa. So it's an octagon. All right. 6 is hexa. 7 is hepta. 9 is nona. 10 is dessa. 12 is dodeca. All right. Other than that, though, all right, obviously we don't have those going further. We just use the number of sides. So if there's n sides, we call it an n-gon, meaning if there's 11 sides, rather than have a fancy name for that, I think there is one, but I'm not sure what it is off the top of my head, we can just call it an 11-gon. If we have 17 sides, we can call it a 17-gon. Has 98 sides, we have a 98-gon. All right, so once we get past 10, all right, 11 and 12 do have names, but if you want to just go 11-gon, 12-gon, or dodecagon, depending which one you want there, that's fine. Once we get up beyond 10, we just start using however many sides it has. All right, a couple of examples. A here, we notice it has 1, 2. Let me redo that. It has 1, 2, 3, 4 sides, so it's a quadrilateral. All right. The next one looks real weird, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. That means it's a nonagon. The next one, 1, 2, 3, 4, 5, 6, 7, 8. Octagon. All right, you don't have to number it there. That's just how I'm keeping track of which sides I've counted already. All right, there's 3 there for you to try. All right, so if you would like to, you can pause this right now, try those. As you've seen on all your other notes, don't know what happened there, the answers are down underneath. All right, now, continuing on now, hopefully you had a chance to try those. All right, next we have what's known as a regular polygon. All right, for a polygon to be regular, it has to be equilateral and equiangular. Here's what that means. The sides have to be the same, are congruent, the angles have to be congruent. All right, we got to have both. All right, all the sides have to be congruent, all the angles have to be congruent. All right, if you look down here, we got a bunch of examples. There's 4. We got a regular triangle or an equilateral triangle, a regular quadrilateral or a square, a regular pentagon, a regular hexagon. All right, then there's a couple that are irregular. All right, the rectangle, even though all 4 angles are the same, the sides are different. The star, even though each one of these sides is the exact same, all right, the angles aren't, so it's irregular. And we have a right triangle there. None of the angles are the same, none of the sides look the same. All right, once again, you have 3 to try. It's kind of just, for these, you kind of just have to eyeball it, so you can't assume on these. All right, for the first time all year, I'll let you assume. All right, but just, are all the sides the same and are all the angles the same? If so, it's regular. If one or both of those is not true, it's irregular. All right, last thing we're going to do is talk about concave versus convex. This is the last way we can classify them. All right, then we have one more topic that we're going to talk about briefly after this. All right, convex, every angle is less than 180. All right, basically meaning all the points are to the outside. There's nothing pointing inside of the shape. All right, so if we look at this first one, points out, points out, points out, points out, points out, points out. If you notice, that's the same for all of those. So convex means that it's pointing out. All right. Concave, on the opposite hand, is when one angle is more than 180, meaning at least one angle points toward the inside of the shape. All right, so notice right here, that angle's angled in, so it's concave. This one, we have that one there, and all those on that corner of the arrow where it starts flexing out. This one, we got that one there, and that one there, where they're pushed in, so the angle's pointing inside of the shape. All right, it's the difference. Concave, it's caving in. Convex, it's all pointed out. All right, then once again, you got 3 to try right there. Are they concave? Are they convex? All right. So far what we've talked about is we've talked about how to classify a polygon. We've done by sides. We've done, is it regular, irregular? Is it concave or convex? All right, those are the first 3 things, and that's it for the first set. So I'm going to take a pause as I scroll over to the second guided notes page. All right, so quick break as we flip over. All right, the second thing that we're going to talk about, polygons, and this is all combined on the one assignment. There's not 2 assignments for this. All right, is what do all the angles add up to? All right, where we're going to start with this is we're going to start with, well, one that we've already done a lot with is a triangle. All right, it adds up to 180. All right, this column over here is if all the angles are the same or all the angles are congruent. So 1 would be 60 because 60 times 3 is 180. All right, now how we get the rest of this, all right, it's actually kind of neat. All right, so if we have a square, awful square, let me retry that. All right, we got a square. All right, angles, all the sides are the same. All right, it has 4 sides. All right, if I go from this corner down here, I can only draw that diagonal. All right, because this side's already there. That's a side, and that's a side. So I only have one diagonal. That means I have one triangle here, one triangle there for a total of 2. Well, 180 times 2 is 360. One angle is 90, because 90 times 4 is 360. All right, we can do the same thing with a pentagon. Oops. All right, we're going to pretend that's all the same. I'm going to go from this corner right here. First off, it has 5 sides. From here, I can't go that way or that way. Those are already there, but I can go across and down. So I have 2 diagonals from that vertex for a total of 1, 2, 3 triangles. So 180 plus 180 plus 180 for the total number of degrees, or 180 times 3. All right, both of those are 540. All right, there's 5 angles, so if I divide by 5, I get 108. All right, I'm going to leave the hexagon and the heptagon up there for you to do. All right, the n-gon, you're looking for the pattern. All right, so I'm going to give you a hint. It has insides. How do we get that number right there? What's the pattern as we go from here to here? What's the pattern? All right, from here to there, what's the pattern? From here to here, what's the pattern? From there to there, what's the pattern? All right, and just write in what the pattern is. So if we added by 7, write n plus 7 or add 7. All right, obviously 5 plus 7 is not 2, so we're not adding 7. All right, but that's what it's looking for. How could we get those last ones? So fill out hexagon, heptagon, then try n-gon. All right, answers are down at the bottom of the page. All right, now, theorem. Here's the big takeaway from this. All right, is no matter how many sides a polygon has, all right, as long as it's convex, meaning that all the angles are pointed out and it looks normal, or what we would assume as normal, we have this formula to find out what all the angles have to add up to. We take the number of sides and subtract 2, and then multiply that number by 180 degrees. All right, so for example, a triangle would have 3 sides. 3 minus 2 is 1, times 180 is, well, 180. A square has 4 sides. 4 minus 2 is 2, times 180 is 360. Notice that's what we got up there. Pentagon, 5 minus 2 is 3. 3 times 180 is 540. All right, so that's our new little theorem that we're exploring here. All right, there's a couple examples here. All right, 2 for you to try and 2 that are already worked out. All right, I'm going to make one more additional one here. That's an octagon. 1, 2, 3, 4, 5. All right, I'm going to do, I don't know if I can, I'm going to try to draw this accurately. I'm not going to get it. All right, we're just going to assume I can draw an 11-gon. All right, so there's 11 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I messed that up. But anyway, you get the general idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Something like that. But here's what my formula tells me. Since there's 11 sides, n is 11. So you take 11 minus 2 times 180, which equals 9 times 180, which equals 0, 72, 1,620 degrees. That's my sum of all of them. All right. If I divide this by 11 to get one interior angle, it would be 100. I don't know why it just did that on me. Sorry guys, I cleared off my calculator. Should be 147.27 degrees. I'm just going to round it like that. All right, that would be one angle. Once again, that is assuming that it's regular and all the sides are all the angles are the same. All right, once again, there's 2 for you to try. All right, answers are down below. If you need any help with the homework, please let me know. Thank you guys for working as hard as you have so far, and I look forward to hearing from you soon. All right, guys, take care.